Okay, we will be starting with this area. Mainly you have to study about what is a continental drift theory is getting, and then we have to understand types and means of distribution. So under the continental drift, we need to first understand okay. Now please listen here. To understand about the continental drift, you have to first understand how our earth has formed. You may have some idea regarding this from your high school classes. Maybe in high school geography classes you have studied some points regarding continental drift as well as plate tectonics. And basically this is what we are discussing here, and a little more new information may be also added to that. And if you look at the structure of the earth, basically if you are looking at the structure of the earth, you can see that earth can be divided into three major portions. The most outermost portion is just like the skin of an apple or a skin of a mango. It's very thin, and that portion is known by the name crust, and we people are living on the surface of this crust. Then below that there is a very large area, maybe extending 1,000 or 2,000 kilometers in length, in depth. That area is known by the name mantle, and below mantle we can find the core. Basically core can be divided into an inner core as well as outer core. Now if you look at the structure of this mantle is basically liquid in nature. You have noticed the what is called volcanic eruptions. When volcanic eruptions are taking place, now what is called magma. What is magma actually? Magma is liquefied rock. When rock is heated under very high temperature, more than 100 degree or 1000 degree temperature, this rock will be melting and becoming a liquid. That liquefied rock is what we call magma. So it is the magma that is coming out when there is some kind of volcanic explosion or volcanic eruption. Here you can see that this is the crust of the crust is the basically the place where we are living. Now if you are taking this outer portion, that is more important to us. This crust can be again divided into two major regions. One is known by the name continental crust, other is known by the name oceanic crust. So here you can find a picture of that. Basically continental crust is that portion of the crust where land or continents are formed. Whereas oceanic crust is those areas of the earth or those areas on the surface of the earth above which we are finding only water or ocean. So this is how the continental crust and oceanic crust can be differentiated. Now based on the thickness also, here you can see that the thickness of the oceanic crust is around 7 kilometers. This is the thickness of the oceanic crust. And if you look at the thickness of the continental crust, it is more thicker, around 10 to 70 kilometers in depth, or the width or depth or width of the continental crust is more larger or more bigger. So that is the basically the difference between oceanic as well as continental crust. Then another point is that if you look at the oceanic crust, it is more denser or more strong. The rocks in the oceanic crust are more tightly or more strongly packed. Whereas in the case of a continental crust, it is less denser. That is, here you can see that it is only 7 kilometers, but it is near to 10 to 70 kilometers. Here in the case of continental crust, the packing of the rocks is more loosely packed. That is why thickness is more. So that is basically the difference between continental crust as well as the oceanic crust. And one more point which are of importance to us is that continental crust is mostly older, then oceanic crust is mostly younger. So this is also another point of difference between oceanic crust as well as continental crust. Now we will see what is basically continental drift. Coming to the continental drift, it is the movement of the earth continent relative to one another. It is a movement that is the continents that we are finding at different parts of the earth today are not in that place always. If you go back to some 250 million years back, we can find that India was nearer to Africa, and similarly the Australia was near to India, Antarctica was near to India. So India was it's a large island floating in the Indian Ocean. Then India moved to the northward direction and hit on the what is called Eurasian plate, and that leads to the emergence of a giant mountain. And this is still going on. That is why if you measure the height of the Himalaya, it is increasing each year by 1 centimeter or 2 centimeter every year. The height of the Himalayas are increasing. And another reason is that from the height of the Himalaya, we still have fossils of oceanic animals. How oceanic animals came there? The only explanation that we can give is that once the Himalayan region or the Everest regions were basically oceans. That is why now we can find oceanic fossils from them. And this hypothesis that continents are moving were first put forward by a person called by the name put forward in 1596. In 1596, there was one person called Abraham Ortilis. Now, Abraham Ortilis prepared a map in 1570. If you look at that map prepared by him in 1570, still see most of the continents are similar to the present day description of a geographical map. So it's almost same. This is the North Africa and North America. And South America is not very proper, but Africa, shape of Africa is almost correct. Shape of India is correct. Then rest of the Asian region are almost correct. Europe is almost correct. So about 3 or 4 centuries back, this person prepared a map of the world, and that map was one of the first suggestion regarding the movement of the continent. Then another person, it was in 1912, another person called by Alfred Wegener. He studied about that. He was also a geologist. He studied about that, and he put forward a theory that there are some movements on the surface of the earth. Our continents are not always static; they are moving by 1 centimeter or 2 centimeter each year. So this movement of continents is known by the drifting. Drifting simply means movement. So this movement of continents is today known by the name continental drift. Now why we are studying about this continental drift? Because it's very important for us also, because as continents move, animals are also moving. So that is why we have to have an understanding of how these continents, what are the reasons for the movement of the continents. Now this is the person known by the name Alfred Wegener, and his hypothesis was controversial, though he put forward in 1912, and during that time it was the period of World War I and World War II, and for about 30 or 40 years people were mostly concentrated on waging war. And after the war in 1950, more scientific evidence came forward and his theory became accepted. There are reasons for that. One is known by the name paleomagnetism. Paleomagnetism is the magnetic property of the earth, especially magnetic property of the ancient earth. Today you know that if you take the poles of the earth, we say North Pole is having North pole is having northern pole of the magnet. That is, Earth also has a magnetic field. So the North Pole, geographical North Pole is today is having magnetic North Pole. But this was not the case always. Today, if you go to the Iceland or Arctic region, it is the geographical north, and today it is also the magnetic north. Magnetic more the northern pole of the magnet will be in that direction also. But before some 250 or 350 million years ago, the magnetic north was not in the Arctic region. It was in the North American region. Sometimes the magnetic north was located at the Antarctic region also. So there was some shifting of the magnetic poles. This is known by the name pole reversal. And these are the studies which are coming under the paleomagnetism. This is a group of scientists, especially physics and geological people, who are studying about how this magnetic property of the earth is changing. So for studies from that area strongly supported that this Alford's theory or hypothesis is correct. Now we have today plenty of evidences. We will see some of those evidences. According to Wegener continental drift theory, according to Wegener's continental drift theory, there existed one big land mass which he called Pangaea. That is around 250 million years ago, all the continents were together. And that single continent was known by the name Pangaea. Maybe you have studied this in your geography textbook of high school classes. So once all the continents were together, and that is known by the name Pangaea. Here you can see that. So once all the continents were together, here you can, this is how the Pangaea was. That is around 250 million years ago. All the major continents Earth were tightly packed and were floating as a single continent, and that continent is known by the name Pangaea. Then what happened is that there was a division between these two continents, and as a result of that, two major continents evolved. One continent is known by the name Laurasia. Laurasia means the present day Asia plus Europe plus North America. That is the Laurasia. And second is known by the name Gondwana land. And that is so there is strong indication about, see, if you take a map and look at the present day Africa as well as India, Africa and South America, you can see that this portion of the South America was very closely attaching. Here you can see that this portion of the South America can be tightly packed with Africa. The western border of Africa and the eastern border of South America are very tightly packed, or it is like a jigsaw puzzle. If you move South America to the east, it can be very correctly placed with Africa. That is one strong evidence in support of that. Then there are also a lot of other evidences also. Here you can see that this was the position of India around 225 million years ago. And here around 200 million years ago, during the second phase known by the Triassic period, you can see that the India is gradually moving northward. So during the time of Jurassic period, when dinosaurs were there, it was during 135 million years ago. The Jurassic period started from 135 million years ago. You can see that the India was mostly an island. That could be one reason why we don't have so many dinosaur fossils in India. But if you go to South America or North America or Europe or Asia, in many places of that, for example from Siberia, from North America, South America, many fossils of these dinosaurs were excavated. But from India, very few dinosaurs were recovered, but from Gujarat region few smaller dinosaurs were recovered, but most of the dinosaurs were recovered from other parts of the world. So if you look at this map, during the Jurassic period, India was mostly an island. That was the reason why there are no dinosaur fossils in our place. Now, around 65 million years ago, India was still an island, and during that period, dinosaurs were during that 65 million of years, dinosaurs were existing. Then, after 65 million years ago, you can see that this movement of Earth was still going in the northward direction, and India finally moved northward and came and hitting on this Eurasian plate. And because of this hitting of the Eurasian plate, the soil and the rock between this place, they gradually moved upward, and that I will show in the next slides. So this is how this movement. This is how the continental drift theory is explaining about the origin of our continent. So once these continents were together, now they have been separated by oceans. Maybe after some years, after some millions of years ago, years later, these continents may be in another position. For example, if you go to Africa, here if you go to Africa, there is one major drift here, called rift here. That is on the Rift Valley of Africa. But geologists and scientists are now saying that this eastern portion of Africa from the Rift Valley will be splitting away. That Africa become two pieces. The eastern piece will be merging with India. So after some 200 or 300 or 400 million years ago, we can see that eastern portion of Africa and the western portion of India will be merged together. And this is going to happen. There are strong indications at that. If you see some safari channel, then that safari channel, he was showing about Rift Valley. It's a deep gap in the African region, starting from Egypt going up to the south. So there is a very deep, narrow gap, wide gap in the Africa, in the Rift Valley, and from that region, Africa will be splitting into two. Eastern will be moving to the eastern side. So this is regarding the origin of a continent. Now we have one more idea, that is plate tectonics, and we will see what is plate tectonics. According to the theory of plate tectonics, the surface of the earth is composed of a dozen major plates and many small, that is nearly up to 10 or 12 major plates are there. And below that, and in addition to major plates, there are also many smaller plates are also present. And we will see the nature of these plates. So these are the major plates that we can find in the case of Africa. Not only North Africa, in the case of the different parts of the world. See, this is the India. India is located in a very small plate. Now you can see the Africa is located in two plates. One is Arabian plate, other is the African plate. Here this is the Arabian plate, and this is the African plate. Then you can see that South American plate. This is the South American plate. Then you can find Australian plate, North American plate, then Pacific Ocean. Most of the Pacific Ocean is acting as a large plate known by the Pacific plate. Then we have Australian plate. So these are the different, just imagine a football. You can see that the surface of the football is formed of several smaller pieces. So each pieces were tightly sewn or stitched with the help of a thread. The surface of the earth is also like that. Outer surface of the earth is actually formed of several larger as well as smaller plates, and these plates sometimes move. When this movement of plates are taking place, and there will be shaking of the earth, and that shaking is what we call as earthquakes. So earthquakes are actually a result of this movement of the earth, movement of the plate with, for example, this is one plate and this is another plate. When they are moving like this, there will be earthquakes. Sometimes what happens is that these are two plates and they will be pushing each other, and as a result of that pushing, one plate will go down, another plate will go up. and as a result mountains will be forming. And when this mountain formation or this elevation of land is taking place in a sea, there will be huge formation of, there will be huge upliftment of water. You might have heard about tsunami. In 2004, there was a tsunami in Indonesia. And during that time, this kind of movement take place and one plate moved above and lot of water also moved above, lot of water were also lifted up. And that water reached different parts of the world. That was how tsunamis were created. So if you have an idea regarding this structure of the earth, especially these outer features of the earth, you may be very well be able to explain why in certain regions of the world there are more volcanic eruptions, more earthquakes are there. For example, if you look at that, this is the this is the Australian plate, this side of South America. Here you can say this is a border of a plate, border of two junctions of two plates, Nazca plate and Samudra. This is a earthquake prone area. Similarly, if you look at this area, this Indonesia area, that is also earthquake prone area. So wherever to this area, this area, this is an earthquake. Here Philippine plate and Australian plates are meeting each other. When Australian plate and Philippine plates are moving with one another, that will be resulting in earthquakes, and also sometimes what happens is that when two plates are moving, there will be gap formation will be there. Through that gap formation, volcanic magma will be coming up, and that will result in the formation of volcanic island. So this is how volcanic islands are forming. So here this is regarding the structure of the earth. There are some more. Now we will see what are the major evidences in support of this theory. One is the fitting of South America and North America. I told you earlier that if South America and Africa were moved to each other, they will be perfectly fitting each other. So that is one most visible evidence for a more common man to understand. Second is that this is how the India, this is South America and Africa can be matched like that. India and Madagascar, that is this western border of India and eastern border of Madagascar, they are very tight, they can be tightly packed or tightly fitting with each other. Then certain regions of Antarctica, this was how all the different continents were located once, some 250 million years ago. So this geographical matching is a strong evidence. Then there are many other evidences, especially from fossil. And if you take the fossil evidences, here you can see that this is a Cyanognathus, a land reptile. This is a Cyanognathus fossil dinosaur-like fossil reptile. This reptile is present. The fossils of this reptile is excavated from Africa as well as South America. So this color is showing the distribution of these animals. They were present in South America and also in Africa. So that is one evidence to support that Africa and South America were once joined together. Another evidence that we are supporting, here you can see that Lystrosaurus. So Lystrosaurus is present in Africa, Madagascar, India and Antarctica. So we can see that they are showing this is of the distribution of Lystrosaurus. This is another land reptile. And from these regions of India, Madagascar and Africa, scientists have excavated or dug out the fossil remains of this Triassic reptile. Then we can also see that another common fossil is the fossil of Glossopteris. It is a fern-like fossil fern that was discovered from Australia, Antarctica, India, Madagascar, Africa and South America. So that is also another explanation. So by examining fossil plants and also fossil animals, we can get some support in favor of this theory. So these are the four evidences coming from fossil. Then I told you about the shifting of the poles. Now this is this is where the present northern pole were situated. But before some time, that is before 400 million years ago, the magnetic north pole was in this point. Before 300 million years ago, magnetic north pole was at this point, and to her 200 it was here, and around 100 this is the present position of the magnetic north. This is the geographic north. Before 100 million years ago, it was more to the eastern side. And here you can see up to when we go to the 500 million years ago, that was this magnetic north was located in the Pacific Ocean. And this movement of poles is because of the changes in the rotation and revolution of the earth, and that is known by polar wandering, otherwise known by shifting of the poles. So when poles are also shifting, there are a lot of changes in the structure of the earth as well as on the movement of animals on the surface of the earth. This is another support for that. And why do the plates are moving? That is another explanation that we have to understand. One explanation given by the scientists is that earlier we had seen that there are three portions for the one is outer crust, then magma, then below that there is a core. That is, this outer crust is actually floating on a liquid, a boiling liquid formed of molten rock or liquid rock. So outer portion of the earth, which we call the crust, is actually floating or moving on a liquid rock. This liquid rock is what we call as the magma, because you might have seen volcanic eruptions and magma is coming out. It is basically liquid rock, a rock which has been changed into liquid because of high temperature and pressure. So because of the tremendous heat of the magma, the plates may be moving. So if you keep a plate, if you are boiling water in a vessel and you are keeping a lid, when water is boiling, you can see that the plate will be moving and vibrating. The same thing is happening here also. Because of the tremendous heat, because of the huge heat it is producing, and because of the boiling temperature below the crust, the upper surface of the earth, that is crust, is getting some kind of push, and that push is actually resulting in the movement of the plate. So this is the explanation regarding why plates are moving. Here you can see that there are basically different types of movements are there. One type of movement is that both plates will be both will be moving away. When two plates are moving away, a gap will be formed, and through that gap, what happens is that this magma will be coming up. That is one kind of movement. Another kind of movement is taking place here. What happens is that two plates are there. One plate will be, they will be pushing each other, and one plate will be going above that. And that is what is happening here. Here there is one plate, there is another plate. When one plate is going down, another plate is going up, and there result in the formation of a mountain chain. And the Himalayas as well as Andes mountains in South America were all formed as a result of this pushing of plates with each other. When plates are pushing each other, mountains will be formed. When plates are moving away from each other, volcanic islands will be formed. So here you can see that this is one plate, this is another plate. South American plate and Nazca plate are pushing each other. That resulted in the formation of a mountain chain here. Here also there is a mountain chain in North America. And if you take Indian chain, here this is the border of the Eurasian plate. When the Indian plate is pushing against that, Himalayan mountains were formed. So this is how the different mountains of the world has been formed because of the movement of the earth plate. Then, so these are the basic ideas regarding the structure of the earth. Why we are studying all this is that because the movement of the animals as well as the distribution of animals, because earlier I told you that why there are no fossil remains of dinosaurs in India? The only explanation is that India was once an island. It was because of that there are no fossil remains on the, because during this time when India dinosaurs were existing, there was no fossil remain. There was no dinosaurs were living in India. That's why we cannot excavate any fossil remains from Indian region. So these are some of the explanation for that, and scientists have a lot of other explanation. Now what happened is that from this period called Jurassic period, between 135 million years ago and 65 million years ago, giant animals like dinosaurs were living on the surface of the earth. Suddenly, from 65 million years ago, we cannot find any evidence of dinosaurs. And what happened is that there was a great death or extinction of animals at the time of Cretaceous period. That is when 65 million years reached, that before 65 million years ago, many of the animals which were living on the surface of the earth suddenly died. And one explanation given by the scientists is that one meteorite means there's Ulka, that's one meteorite hit on the earth at that time. And that hitting of the meteorite is like explosion of several nuclear bombs. Some 1,000 or 10,000 nuclear bombs are exploding all on a time. What will happen? Lot of dust will be moving up, and that will be blocking our atmosphere. When atmosphere is blocked like that, there will not be any sunlight coming into the earth, and that also resulted in the death of the animal. And that period is known as a period of great extinction. And scientists have an evidence for that. If you go excavate the earth and reach a point where 65 million years of soil, we can discover soil around 65 million years back. And when scientists are discovering that soil which are of 65 million years back, they found a mineral called iridium. Iridium is a mineral which are not normally present in earth, but this mineral is present in meteorite. So presence of this iridium is another great evidence to prove that a meteorite has struck the world around 65 million years back. So these are some of the other evidences that we can find. So if we know how these movements of the continent has taken place, then only we will be able to explain and the present day distribution. Why there are no elephants in many parts of the world? Now elephants are only present in Africa as well as India and some regions of Asia. There are no elephants in Australia. We should be able to explain why this is happening. So when we are studying about this movement of the continent, and when we know how the present positioning of the continent has taken place, it will be easier for us to explain how this continent and how this distribution of animals has taken place. So in the next class, we will be discussing on the distribution of animals, and there are a lot of points regarding that. So this is regarding the origin of continent as well as plate tectonics, and you should know who is Alfred Wegener and what was his contribution.